Okay, we're recording. Thank you so much for joining, Shain. So for people watching, this is also going to be on the podcast, the AI Security podcast. For people listening to the podcast, this is also on the Harriet Hacks channel. And we're joined by Shain Singh, which is such a delight. So thank you. Do you want to tell us a little bit about who you are and how you fit into machine learning security?
Sure. I don't know if we do good mornings or good afternoons. Depends on when your listeners sort of watch this. So I'm Shain. I've been working in IT or security for over 25 years now. And how I met Harriet, and we're going to probably talk about that, is I happen to be one of the project co-leads for the Machine Learning Security Top 10. And what that project is, there's a few projects that sort of handle that space. The Machine Learning Security Top 10 project concentrates more on the ML side of things, right? Which sort of underpins some of the generative AI and things that you specifically probably hear about now, right? And I came into the project from largely an application security background, I would say. So yeah, we'll start with that. So lovely to be here. Thank you.
Thank you. No, it's amazing. So the last time I saw you was in Melbourne. Tanya and I were there for the risk analysis conference, which we've also spoken about. But we caught up for drinks along the river, and it was the first time that we'd been properly able to chat, especially about your experience. And it's so interesting. I know our listeners would be really interested to know a bit about your early career and how starting in your field was able to help you get into AI security now.
Okay, cool. Yeah, look, before I start, I'm not a big fan of like talking about myself on these sorts of things, but I understand that some of your listeners are probably early into their career and sort of want some guidance around this stuff, right? So my early career started in what used to be called system administration, which is the running of servers, and typically they were physical assets 20, 25 years ago. And back then it wasn't, the word cyber wasn't even used. It was called information security largely. These days, if you want to sort of have a similar term, they're called SREs or DevOps, basically people that can do a little bit of scripting and coding and run the infrastructure. Sorry?
What does SRE stand for?
Site reliability engineer. So it was a term that was popularized by Google, where you weren't just the person that runs the server, but you actually have an understanding of the infrastructure and the applications that run on it, right? It actually, this is quite interesting. It happened at a time where there was largely a divide between the people that ran the infrastructure and the people that ran the application. So if I go back to about 15, 20 years ago, if I was on call, right, I used to work at an ISP, and people can go look up on LinkedIn where that was.
Can you also
Oh yeah, okay, sorry, yeah, I'm talking about stuff that maybe people don't know. ISP means internet service provider. Yeah. Sorry, no, this is good. Sorry, this is it's very handy to have people sort of check you on assumptions that you have in your own head. So thank you for doing that. So ISP is another term, is a word for internet service provider. So basically, who provides your internet, right? You can call them telcos as well because they generally provide phone services and things. But internet service provider. So running that as a business. What are the things that you did in those days? It was like DSL, which is before NBN type services. You had services like DSL, but the services that you provided to the customer, some of those are you can call them free, right? DNS services, parental control, some of these sorts of things that you typically get. You either charge for some, or some of those are just part of running a service, right? VoIP was another one back in those days. So some of those you have for commercial, some of those you have for residential users, right? Now, running those servers and that network infrastructure were largely two teams. So you would call them networks teams or systems teams effectively. Largely, I would say Unix or Linux-based infrastructure with some Windows stuff as well. right? And I think that's important. So then when you would actually have applications, there would be physical servers that you would run, and you would have an application owner, right? Let's take something like, what's a good one? Radius. Okay, Radius, or so Radius is a acronym. I can't remember what it stands for off the top of my head, but it's basically the authentication service that's used, right? So when you log on to something, it's a way of doing authentication and authorization. So when you logged on to an internet service provider, for example, it needs to know that you're the right person that's using your login details effectively, right? So that infrastructure, you can either use open source versions or you can buy commercial based versions, right? The application owner for that would say, hey, I need to run this somewhere, right? It runs on Unix. Okay, cool. So back then what we would do is, server or network infrastructure sort of designs. Okay, what are the specs of this application? What does it need to run, right? These are sort of things that don't get thought about as much these days because the cloud sort of abstracts some of this stuff for you, right? I don't want to spend too much time on this, but like it's interesting because it sort of helps with the foundational knowledge of how things run, I guess, right? That's probably why it's helped in my career. So you would get specs, how much storage, how much CPU, all these sorts of stuff, but then you may not, depending on the application, get high availability type scenarios for that application or security type scenarios. So in those days, you would just get a vendor might say, here, go run this. And, you as a security person would say, you're running this on default usernames and passwords. Well, sure, you're a large internet service provider. No one's going to break into your network. Only we're going to come in and physically, if we have to do some, third level support or things like that, we're the only ones that know. This is the kind of stuff that used to happen. It was very, very common, right? Inside network infrastructure, it was very common because people didn't think that you would be able to breach inside networks very easily. It was in that era of if your listeners are familiar with what we call zero trust now, you effectively had a moat or a perimeter of how to get in because things weren't distributed and they weren't everywhere. Okay. So that's the world that I sort of started in, and the industry was actually very cool. I was very lucky to work in a place like an internet service provider because you interacted daily with application owners, you interacted with network infrastructure, you interacted daily with other system administrator, and it was a close-knit team. There was always friction sometimes, but you got to learn about lots of different things, right? Again, in this day and age, there are ways to do things like if your listeners are familiar with things like DevSecOps, this is where you're putting either a security person into a DevOps or operational kind of team, or it could be that you're training a champion in that operational team, right? Either or, right? In those days, we didn't really have that luxury, but we tried as best as possible to work in all of these environments, which is also good for your career because you could, at some point in my life, I actually went to do network infrastructure, right? Like vendors like Cisco and Juniper and technologies like MPLS. I'm not going to explain what that is to your listeners because it's not relevant, but like it's an old legacy technology, right? So you got to play with all of this sort of stuff, and overarching over all of that is meant to be security, right? Information security as it was called then. And largely that dealt with, I would say that authentication and authorization were quite important, but identity wasn't as important, I will say, because it wasn't in a world where we had, Google to log you in like OWASP type scenarios that we have now, right? Use your Google login or use your Microsoft or Entra login, those sorts of scenarios, right? So I guess where all of that stuff helped was to be able to, you call like T-shaped sort of engineers, right? Where you got a lot of cross-functional skills, if you wanted, and you got to learn about lots of different things. I would never call myself, for example, a database administrator, but I sat next to one, and sometimes I had to help troubleshoot from the server aspect that the database was on, a problem statement, right? So while they were dealing with something wrong with the database, I was seeing if I could help from the server that the database was on. Is there something wrong? So you got to sort of learn the language and play with these sorts of things, right? So from that, I got more and more interested in applications, because I felt like, and this is just for me, largely all of that infrastructure stuff, my analogy would be, it's like building highways. They're cool for people that build highways, because there's a lot of civil engineering that goes into thinking about how those things are built. But for most people, they don't care. They care about where they're going from A to B, right? Mm. From neighborhood to neighborhood, to shopping centers, to whatever, to recreational reserves, things like that, right? And that's the kind of analogy I use to talk about applications. Applications, to me, were the things that ran on this infrastructure, and they're cooler. And that was, I would say, around the time where the iPhone actually was released. It was around that time, so 2007, 2008. And, this concept of app stores and, having, hundreds and hundreds of apps on your phone and walking around with a computer, that was just, the beginnings of that, right? And so a lot of the people that I work with sort of migrated into those sorts of fields where they got to do more closer to the application type scenarios, right? Whether they became software developers, whether they went into work at technology vendors, like myself, where I work at F5, and there's equally others, right? So from there, I started working at where I am now, actually, at F5. So I've been here 13, coming up to 13 years, long time. And that's been very cool, because having that role, you're kind of like a consultant where, I started in the professional services team. So that means that, every week a customer's got a problem, and they're paying for F5 to come help fix that problem. And a lot of that required speaking with lots of different teams, right? You would actually have to speak with teams that maybe the organization themselves didn't want to talk to, right? In a lot of organizations, networks people don't talk to systems people, don't talk to security people, don't talk to application people. And then you're having to go in and, make something work because it's on your equipment, right? And so that's been a whole lot of fun, because I think, I am a people person and a technology person. So you can marry those two things up, where you're always talking to new people, you're always dealing with different environments, and you're using technology to solve those problems.
So how did you how along that journey did you become acquainted with the field of machine learning security then?
Good question. So I would say it's probably 8 or 9 years ago now. I think people may have forgotten that, just like we're hearing about AI tapped onto everything right now, people were saying machine learning, probably about 8 or 9 years ago in all vendor technologies. And that was while I was at F5, right? So what was happening was like, hey, our security technology is great because we use machine learning, or blah, 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 blah. So there was a bunch of that. So that was my first sort of, run-in with what machine learning is. It's not something that I studied. I did a master's in maths, but it was in crypto. So I was not a statistician.
I think that means you're already a few steps ahead of a lot of people, though. So you did a master's in math and cryptography as well. How did that contribute to your role? Like, how have you been able to use that very much?
No, I mean, I actually did an undergrad in aerospace engineering and then a master's in crypto. But no, I think it didn't. No, I'm not rich and I don't have my own Bitcoin or anything like that. No, I think to be honest, I would say that I did the master's in crypto more as an intellectual curiosity than as a career progression, actually. Now, I'm lucky that I had what was the start of a career to have that luxury to do that, I guess, right? Because a lot of people...
I'm inclined to think that sort of algorithmic thinking, though, must be really good when considering machine learning problems and their weaknesses too.
I would say I got a lot of that from my aerospace engineering degree, right? Like engineering, I feel by definition taught me two things. One, to learn how to work in groups, right? Because that's just how corporations are and how communities are. You know, so you'll never do everything yourself, and that's a good thing, and that's also a bad thing, right? And you just have to live with it because that's the world that we live in, right? But it also fundamentally taught you how to problem solve, and problem solving from, yeah, I guess you could call it algorithms, not necessarily always from a programming aspect, but there is still an algorithm in terms of a way of thinking about how to break problems down, right? How to troubleshoot things. You know, there's like theories on how to do troubleshooting, like do you halve the problem and then look over here, and how do you do, you know, how do you set a hypothesis and try and prove it wrong, and all of these sorts of things, right? And I feel like it's not like you study that in engineering, but you do it, you know, you do it for all the problems that you're sort of given. So definitely that was a huge factor, I think, in my career. Both those things, learning to work with people and learning how to problem solve. It sounds, sorry, I'll just sort of mention, it sounds very like airy-fairy and high level, but really it's so, like, when you meet people that don't know how to do those things, it's very apparent, I'll say.
Yeah, that's really interesting. A lot of the questions that we get from listeners are often about like the best study path, the best way to get into certain fields, sort of talking about those common, I guess, benefits of degrees. Like you can study lots of different things and learn those really important sorts of skills. So you became familiar with machine learning because of the machine learning hype that I also remember really well. How is it that you became familiar with the weaknesses of machine learning models? How is it that you got from there to becoming one of the co-leads of the OWASP ML Security?
Oh, okay. Yeah. I'll collapse that into, so I've always had I guess this came from the engineering background, or probably just as a personality, there's an engineering personality of wanting to see how things are made, right? Like so breaking things to work out how to fix them again, right? And that's important, not just breaking things, but breaking things to work out how they fit again. So, you know, if you want like the stereotype that's like kids that play with like Meccano sets and Lego and things like that, or, you know, I used to always break my toys to work out where the noise was coming from and all those sorts of things, right? So that, funnily enough, has a very, you know, easy path into learning about things like penetration testing and the, you know, you can call it ethical hacking, or just like how to look at the security of software and systems, right? So somehow that sort of marriage happens quite easily, I will say. If you have the idea of like wanting to tinker with things and going, hey, I wonder how this works, because maybe a lot of your listeners aren't familiar, just like the words AI and ML, the real definitions have been conflated. Some of us, like old timers, we would also talk about the days where the word hacking, you know, has also been conflated from what it used to mean. Hacking was just, you know, you're a hobbyist. You know, you're hacking not as a malicious intent. You're pulling apart your laptop to work out how it works, or you're soldering your own motherboards and things like that. That's where that term sort of came from, right? That ship has long sailed, but but effectively that's the mind of a person that sort of gets towards thinking about security, I would say, right? And so from that, when I see something like machine learning, it was, again, looking at it from that point of view, and I go, so if this was more like a personal thing rather than doing it for work, but it was like, if two vendors say, here's a thought experiment I used to have. If two vendors say, I have machine learning, so my technology is better than yours, I just say, well, it's like saying two children that have been trained on something, you can prove how this is better. And like being on the non-vendor side for a long time, I was like, well, if a customer can't prove that, then what's the point of making that claim? It doesn't stop anyone in the industry, right? Mm-hmm. And so that was the kind of like, to sort of give you an understanding of how I wanted to think about this problem statement. So it's like, well, how can I validate that one model is better than another? And maybe I can't, as an expert in machine learning, but how would I do that if I had to evaluate software, right? And so that was one thing, and then so taking the sort of the adversarial sort of aspect of it to just say, this is a bit crazy, just like the stuff that I'm sure folks have seen with you, like all the ways that you can manipulate image recognition systems and things like that. Like before I'd even seen any active sort of examples of that, I was like, well, surely this is going to happen. It's just a matter of when, right? Mm-hmm. We're dealing in a world of ones and zeros, and it's quite easy to, it's relatively easy to fool humans. It may be even easier in some scenarios to fool machines, right? Because they're being trained very specifically on a thing and not much else, right? That was kind of how I thought about the problem statement. And I was like, well, I'm not clever enough to do that stuff, but I'm sure some people are. And so watching all of the sorts of things that came out, right? Like people, the funniest ones that used to exist were like the memes where people would put cross SQL injection. So if your listeners aren't aware, an SQL injection is where you can put in some input. Likely the application's talking to a backend database for some things, right? So an SQL injection means that you're actually putting the database query inside your input, and so the application doesn't check the input, and it goes straight through to the database. And the database may, depending on what that input is, they may either read, write, drop the database, delete data, or whatever that happens to be, right? So there was an example of that in people that used to put that across their license registration plates on cars, right? That's one of the first things that I ever saw, and that was like the cleverest thing I ever saw, because image recognition systems that pick that up, that would just like theoretically that would wipe their database, right? And I've seen other things like that where people wear clothes so that they don't show up on, they're completely a ghost in front of cameras. So all of that stuff kind of sounds cool, but I was like, again, looking at it logically, I was like, there are, I don't know, it just seemed like there was going to be ways to break this, right? And it got me to a point where I was like, well, how is it that we're actually even going to try and protect this, right? That's the sort of things that I was sort of thinking. Again, this wasn't through my work, but more just externally, right? Like, what are the sorts of things that exist? Then what happened is probably about, I think it was about 23, 22. When I've forgotten, it feels so long ago. When did GPT release? It was about 6 months before GPT. Yeah. The marker is I know we were before GPT. That's all I know, right? So before 6 months before GPT, myself and one of the other project co-leads, we had a chat with OWASP about creating a machine learning security. So like we met, that's a separate story as to how myself and Saga met. And he had a list of things that he thought this is a good start. And what we need is for a community of experts to come back and pick at it and tell us what's wrong and what's right and how we do that, because it effectively just came out of the head of two people, right? Mm-hmm. And OWASP is a fantastic organization for two things. One, because of the reach that it has into and the credibility that it has. But two, and this is the bit that most people don't realize, is it's very, very grassroots and open source, i.e. you don't have to be an expert to start things necessarily or contribute. And this is important for your listeners, right? So there are lots and lots of ways that you can contribute, even if it's fixing spelling mistakes, even if it's just being the megaphone and advertising the project. I think that's a valid contribution in itself, right? So, you know, we had a chat with OWASP, and you know, there's a bunch of admin stuff that they have to do to enable the project. You know, GitHub links and part of the OWASP, the GitHub organization and things like that. And then, yeah, we put those details up, and then slowly got a bunch of people. This is the fun part. It's like we've done this without not much like exposure. Like, as in, we didn't really advertise at the wazoo about this. And we started getting people joining the Slack channels and wanting to help, right? And I was like, that's pretty cool. And where we're at now is we have a bunch of people that want to help, but it's like corralling them into places where we think that they can help, right? So I think, let me just see. And we did hop, and sorry, I digress quite a lot. I get excited about this stuff. I think I did get to like how we got to that, right? Yeah. So
can you give a bit of an idea of what's on that list?
Yeah. Well, I mean, here's an interesting thing, right? I was thinking about this before joining this call as well, right? If I was to explain the top 10 firstly, just to folks, there are actually what we would like to do as part of OWASP is actually two projects. It wasn't just the top 10. There is another one that we've sort of had, I'll call it incubation, but we've got to put some stuff up, which is called the Machine Learning Security Verification Standard, right? So if I was to use a really rough analogy, the OWASP top 10 is like the TikTok version, and the verification standard would be like the long form essay, right? Mm-hmm. And what we mean by that is a top 10 is typically, at least from OWASP's point of view, as similar to some of their other projects, is more like an awareness campaign, right? It's a what can go wrong. And so the what can go wrong, you know, some examples of things on there are things like model theft. Actually, here's an interesting one. I'll give you an example. Two of them on there are model theft and model skewing, for example, right? And so there was actually some feedback just recently. They sound like the same thing, right? Because you're going to get output, and maybe the mitigations are the same. I was like, well, there are scenarios where they can be different. For example, you know, there are certainly similarities between model skewing and model poisoning. And, you know, to explain some of this, like skewing is where you could influence the model to sort of make it do things that it wasn't intended to, right? In a scenario. And poisoning, as the word suggests, is deliberately putting in malicious input for some form of malicious output, effectively, right? So there is an example of where there might be a difference is you can have skewing by unintentional biases that have been put into a model. So that's not necessarily malicious. It may be, but we don't know that. But a bias put into a model can have unintended consequences, and that may not be the desired intent of the person that created the model or the person running the model, right? And so the mitigation for how to look after model skewing may not necessarily be the same as what you need to do for model poisoning, right? Mm-hmm. Another thing that I'll sort of describe with the top 10, please don't have to remember all of them because I don't remember. Again, I'll tell your listeners to have a look at the website is ML Top 10, the number 10. So MLTOP, the number 10.info. So MLTop10.info.
I'll include a link in the description as well.
Excellent, thank you. One of the other things that came up as we did this is exactly what I just described. Is there's nuances where some can be similar to others. There isn't a direct line where you say, this is how I protect against poisoning, or this is how I protect against inference, or this is how I protect against that. To me, and at least to the folks that have sort of contributed so far, that's perfectly okay, right? I'll say something a little bit controversial here, but the top 10s aren't, in my view, written so that technology vendors can just like go create I can do a top 10 because I've mapped to these sorts of things. They're meant to be given as, here's the risks and here's potentially some ways that you can think about mitigating these risks. And yes, there is overlap between them, but there are nuances that you should need to know about because that's important, right? Before the intent here is awareness about the risks, right? If I go on to like the top 10 versus the ML SVS, which we haven't started. So the top 10 should be like what not to do. And the verification standard would be like, this is how you verify the security of your machine learning systems. So that's like an audit or a checklist or some sort of rigor that you can put against your models. Mm-hmm. And we're replicating what's been done in two of the OWASP flagship projects, actually. So the project that OWASP was firstly created for, the original top 10, was for web applications. Now that's the what not to do, and then how to look at the security, or verify the security rather, of your software. That is a project in OWASP called the ASVS, which is the Application Security Verification Standard. So there's a levels, level 1, level 2, level 3, right? That is something that we intend to do, and there is some overlap, but like I said, one's a TikTok version, one's the sort of the long form version. The intent for all of this is for people to sort of understand the risks, but also how they can sort of validate their systems and hopefully get better security, right? Uplift their security posture.
Mm-hmm. So you mentioned before the difference between ML and AI, which is not trivial. And especially I see as AI has evolved over the last few years with large language models and more agentic systems. I often see the scope of ML being more of the model and AI being more of a system, and especially more so an agentic system. So how do you think things like ML security continues to stay relevant in an era of more agentic AI?
You asked a very tricky question. In fact, I think we talked about this question when we last met in Melbourne, right? This is the $10 million question, right? Or the $5 billion question. I think, look, there's two ways I think about this. One is, what's the intent of any of this stuff? Why are we doing all of this, right? It's to hopefully protect ourselves, our neighbors, our parents from using systems that have been, that are compromised, or so they don't get breached, right? End of the day, we're living off this data or this software, right? So at some point, it doesn't matter about the definitions at some point, because the intent or the objective is we're all getting to like uplifting security. Now, one of the things that I actually learned by reading your report, right, your interim report that you and Tanya did, actually, and that was a very good way to put it, is if we don't necessarily have a definition between ML security and AI security, we may miss the reporting of this stuff. And so it may get misaligned with how we go deal with it. And let me explain what I mean there, right? Is we've had probably, I'd say, almost close to a decade's worth of public breaches around cybersecurity, as an example, right? And some are public, some are not so public, some are in places like Australia, and some increasingly in other places. You're being governed. It's part of the bill if you're critical infrastructure to be notifying people when you're being breached and things like this, right? And we learn from those breaches, right? What not to do, right? Now, I feel like the AI security and ML security, like the differentiator in that, some things, and again, this is stuff that it's still formulating in my head as to the differences, but I liked where your interim report was going, is that if people largely miss the classification of stuff into ML security, we're not necessarily going to learn from it in the right ways, likely, right? Let me give you an example, right? Like as you mentioned, like AI, I think, is becoming more about the whole system these days, right? Like the original word AI is long gone and lost because of large language models, right? So really, we're talking about the model, its interaction with applications. It's if you're using a UI, effectively that's like the front end web app, so that's like just pure AppSec at that point, right? The interactions between them is just pure APIs, right? So that's API security, or RBAC, or identity management, and all those sorts of things. And then now, we're getting to that stage of all the buzzwords like agentic AI and MCP and all these protocols, which again are just API-based interactions, and then payloads that look very close to things like YAML and JSON. And then, but talking the structure is in something that we've seen before. The context is a little bit different, right? Now, if we see issues in that space right now, my hat at F5, I will say, right, will say that that's an API security breach, right? That's like you not doing API security properly. Now, does it matter if I didn't classify that properly as AI security? I don't know. I haven't really, perhaps if we meet in 6 months or a year's time, this is a work in progress, right? Because it's going fast. One thing I will say though is people at the moment, it's very easy to get caught up in just the hype phase of things, right? And the reason things like machine learning security exist is because I would call those table stakes, or the basics, right? You're doing, if you're likely to be integrating AI or some sort of model into your environment now, the majority of people are going to start from I have a model and I'm doing something with it. Where we're looking at this problem statement from is there's problems with that thing that you just got, and it's not just I got it from a malicious source. There are some other things that you need to potentially think about, right? Now, do we all trust all of the biases or information that's been put into some of these foundational models? That's a risk that ML security thinks we need to discuss and talk about, right? Certainly through my work at F5, I do work with some organizations that I will call on the 1% end that are buying lots and lots of GPUs and doing their own foundational models and things. And so they're people that I can definitely talk to about machine learning security, right? The other point to this, I'll say, sorry, I've talked for a long time, but it was just coming straight out of my...
What we're here for.
The other point to this is and I think you're the same, I'm a big believer in fixing the problem at the root cause. And what do I mean by that is all these years in application security have taught me that I can get more impact if I help developers do security properly, and not come at it from the point of, don't you know what you're doing? They do know what they're doing. They just don't know the stuff that I'm trying to tell them, right? About the security aspects of it. They're not necessarily malicious or inept at their job. They just don't think about it from the security lens. Machine learning security, I feel, is in that same boat, right? I can talk machine learning security to a security or a governance person, or the people that do all things security and all the things. And yeah, that's likely to have rules and structures and guardrails placed around the use of it in an organization. But I feel like there is more to gain by talking to the practitioners. And in machine learning, that would be data scientists and machine learning engineers, right? Or ML ops people even, right? Who may not necessarily be people that even write the models, but are like responsible for running the models, depending on where you work. So I feel like it's needed because of the role that you do right now, right? And where there may be likelihood of having more impact, right? I can talk about the ML top 10 to security people, and they read it and they go, oh yeah, cool. Like, how do I buy some technology that just like makes this all go away, right? Oh, that's I don't know what did that. But like you and Tanya went to like a data conference, right? What was it? Remind me again, what was that?
It was the risk analysis conference.
Risk analysis conference, right? Like, so people at that conference, right? Like talking to them about these sorts of problems, right? Now, they may be aware of these sorts of things, but I'd like to spend more time in those scenarios to just go, how do you think about these problems, right? Because again, I think that conversation is more likely to have more impact.
I also really like, I really like all of your answer. I think it's really interesting because there are a few people now that I hear talking about agentic AI and MCP. And if people aren't familiar with that, that's the protocol that enables agent-to-agent interaction. And a lot of people say that, yeah, that core ML security principles aren't necessarily going to be relevant in the future. But the comment you made about the 1%, I think is really important because, yes, there are companies like Microsoft and Anthropic and OpenAI looking at frontier model development and being able to do like red teaming of agents in sandboxes where they can do cool things like show, I don't know, pop-up boxes on websites that have SQL code and ask an agent if they, see if the agent will actually interact with that code or whether it will stop, whether it recognizes that's a problem, things like that. But the rest of the 99% of organizations are probably using narrow AI models like conventional neural network style architectures where they don't necessarily have the tools or the teams or the scope or the knowledge to be able to understand all of the security implications. And most of the organizations we work with are still at scale implementing, more of those narrow machine learning solutions where this is still really important. That can be in like finance, banking, healthcare. Agentic AI will definitely become more important, I think. But I always think of that quote by William Gibson, like the future is here, it's just not evenly distributed. I think that's really, really relevant in the context of ML and AI. And it will be for a long time. And it'll only get more non-distributed over time, I think, especially as we start to have lots of legacy AI and ML systems from different companies and projects that don't continue. What do you think of the key, I don't know, trends or takeaways or things that you wish more people were aware of?
Okay, so on that, and also just a comment on what you said there, right? Like that in order to talk about the trends, just a comment that you made that some people may be thinking that ML security may not be relevant in years to come. So I'd encourage your listeners to watch, there was an OWASP New Zealand conference last year, and Andrew, who's the executive director of OWASP, is an Australian guy actually, talked on that. And here's something that people don't know. The OWASP top 10, the original top 10 that was created in 2003, that has largely stayed the same top 10 for 25 years. Now, shock horror. There's two things that you need to learn from that, actually. One is we still haven't got good at fixing things like cross-site scripting and
People still think good.
That's one thing. The second thing is these things are hard, and it's not about they're fundamental things about how to write software. So you're like, I feel at the moment like where we are getting the machine learning security top 10 to is largely the top 10 may not change, right? These are the risks. I don't know that yet. We need more people to sort of give input into that. But I don't feel like those things will change. We may get better at thinking about how to solve those problems, but it doesn't need to keep changing with the times, because these are the things. It's like a checklist of things that you need to think about, right? That's the first thing, right? So second part of that, and sort of goes into the trends a little bit, is I'll just mention that one thing that people don't seem to talk about, I've found, is how to build this stuff. And that's some things that I've been exposed to in my work at F5, where if I talk about the 1% of people that are dealing with their models, or even the 99% that are integrating models into chatbots and things like that, where are they going to learn? Where is the place that teaches you how to go create a model and add a chatbot into your existing application? Where is the place that you go learn about, this is how you buy servers with GPUs, and this is how you train your models, and this is how you then serve that model to anyone, right? Largely that information is coming from the vendors that they happen to buy the technologies from. And this is not a dig at the vendors. That's fine. It's a reference architecture and those sorts of things, right? So that's perfectly normal, right? Whether it's a cloud provider or whether it's infrastructure providers, you go, hey, how am I going to run this stuff? Well, here's our, best practices guide. If you look at those best practices guides, at least some of the ones that we've seen, it's like 25-year-old problems that we solved, right? Which is crazy. So just to give you an example of some of the problems that are seen in these places is like, if you are a person that is serving a model, you may not necessarily be serving that model just to your own internal stuff, i.e. you don't need tenancy, right? You don't need a multi-tenant environment. If you need a multi-tenant environment, how are you serving that model so that everyone gets their own version of that model? And more importantly, how does that infrastructure look so that the connectivity between the model and any of the other interactions are happening also multi-tenant? Without going too much into it, some of these problem statements, they're like working on flat networks without any sort of, compartmentalization, some of these sorts of things that we've seen, because people want really fast, sorry, my screen saver went on there. People want really fast networks when they're dealing with storage and, when you're dumping data, when you're doing things like RAG, and they haven't thought about these security problems because they're like performance, GPU. But we solved all of these problems. And again, what's the first thing? No one's going to get into your storage network to talk to your RAG. And I was like, well, hang on, because right now, another thing sort of happening, this is an important digression. One of the other things that's happening specifically with AI is large organizations that I talk to, and I'm sure you talk to, and I'm sure that your listeners work at, all of their data is all in very, very different places right now. Like you have logistics data, you have Databricks, you have Snowflake, you have Salesforce, you have Siebel, you have all of these systems. They are likely rushing to put all of this information and vectorize them and put them into what's called a RAG. And for your listeners that don't know, a RAG's just a way of saying to a large language model, use the context of my own information when you're serving these answers. That's a really high level way of explaining it. So you've gone and taken all of these disparate pieces of data that your organization owns and likely put them into a consolidated place. So it's running in a database. Guess what that place is? Your intellectual property and the keys to your kingdom. Now, have you heard anyone talk about the security of how to protect against that RAG or that database? No, right? Everyone's talking about agentic AI and things at the back. Now, there's all of these sorts of areas that I feel like need more people talking about them, right? And I think if I sort of talk about the trends, I think that sort of answer's been taken from me, right? It's agentic AI and MCP and those sorts of scenarios, because people are trying to work out the easy factor of how to connect models to useful things, right? And how much agency you can give these things, right? That was actually one of the top 10 risks in the large language model, which is over reliance or excessive agency, right? They changed the naming. I forget which one was which, but over reliance on these things, right? So it's like, yeah, go do my thing for me, right? I think that's a risk that is not a technology risk, right? It's a how to think about that risk. So I feel like we're going to be hearing about how to connect AI to all the things. I think that's the trend. I would like the trend to be more. I would like the internet and blogosphere to be talking more about how to build these things, right? And that's a shout out to people to maybe do that, and maybe to myself to start writing some of this stuff as well. Is, hey, how do I go from zero to building this stuff, right? And what does that look like in an organization? Because it doesn't look the same as doing it on my Mac or on my Pi, Raspberry Pi, things like that. And what are the things that I need to think about? And how does this look different to a normal application?
Yeah.
Right.
Yeah, I think that's a really nice note to sort of close on. There are lots of pieces of the puzzle that still don't get enough attention and research. And thank you so much, Shain, for all the work you're doing in the field. I'm going to drop the information in the description about how people can get in touch with the project and contribute as well. But I'm also really grateful that you came on the podcast. This has been a really interesting discussion, and there are many rabbit holes, but yeah, I appreciate your generosity with your time.
Thank you. Thanks to everyone for listening as well. Thanks, Harriet.
Thanks, Shain. Bye, everyone.
Bye.